we started a new chapter, and I asked you to bring the NCERT. Which class is this?
9.
I see.
CB.
The CB, right? I did ask you to bring NCERT.
School book.
No, NCERT textbook.
The second one.
I did ask you.
Yes.
The volume as well as the textbook. Did you or did you know?
Textbook. No, you didn't take it.
I said both, but it seems you misunderstood it. Alright, so but if you have got the volume, please show me the volume. And if you have textbook, show me the textbook as well.
Yeah.
So,
I'll take your data.
we'll connect this. Maybe looking for the textbook because
I seriously forgot that we have to bring the volume.
when do you know?
Last night.
Yesterday you forgot to remember.
No, I did that.
Did you? Two paper classes. Alright. Today it's alright.
For next time, I'll.
Not there won't be any next time, any which way. I won't be giving so many details all the time.
Okay, but for next time, I'll make sure that I do.
Make sure today I'm going to be open. That is why I asked you to bring NCERT and volume both. But
As I go home, I'll do the homework.
it's up to you. Today, maybe tomorrow, but do and come next class. Otherwise, you will be deeper. Shall we start now? Is it done? Yes. The last class we started with new chapter and we introduced one really importantly, which is Anirudh you left completely. So we did introduce first second law as well, and I think by that time we went. But were you there for inertia when we discussed inertia? Alright, so both of you we can get quick recap. Can you know what is inertia and or at least like the first law of Newton's first law?
I know the second.
You know the second.
Momentum into speed is equal to force.
Everything, you can whole khichdi. Just say what is momentum, only tell that much. Very good.
Yeah.
Yes, sir.
She is not Yona, I know that.
Can I take the forms?
Okay, tell me the first one. I wanted the first one. Yeah, there's no formula. Anirudh, you were there for the first law of motion?
No, he was.
Yes, right. Can you tell me the first law of Newton's law of motion?
It was like when there is no friction, something. It was like sort of
Yes, very close.
ball. If the friction is less,
Yeah, I remember. When there is no friction, the ball is kind of very rough. And when there is friction, which like an ice that, then you roll a ball and a ball goes very fast.
it needs a friction to stop or it repeat.
So friction is what? A kind of force?
Force, yeah.
Yeah, so there is external force. So if there was no friction, so basically there was no external force, then ball would continue what?
Moving.
That means be it and basically यहाँ पर friction अगर friction नहीं होता, मान लीजिए friction नहीं है, so the ball will keep on moving. But if I have to stop that ball from moving, what do I have to apply? Force, right? Muscular force, या friction force, या anything. So basically, without any external force, अगर आपने कोई external force डाला नहीं है, तो object जो काम कर रहा है वही करते जाएगा. चाहे तो move हो रहा है तो move होते जाएगा, और रुका हुआ है तो रुका हुआ ही रहेगा. So the first law is the most easiest one. It says that object will continue to be in state of rest or that of uniform motion. जब तक हम क्या नहीं apply करेंगे? Until external force is applied. So it's not that difficult to understand, right? And neither it is difficult to put it in terms of words. Zed, did you bring NCRT textbook?
No, ma'am.
Volume 2.
Yes, ma'am.
Alright. Alright, no problem. I wanted to give some questions from the NCRT. Okay. So the first law of motion. Has he switched this on or not?
Oh, yeah. 1 minute. Ma'am, inertia is the tendency of the body to resist any change in the state of the rest or of its motion.
With this reading, explain what is inertia. So first, Newton's first law.
Ma'am, there are 3 laws, right?
Yes, there are 3 we have done first. So the first one is Anirudh, this is especially for you, like they are saying, if any object is moving, it will continue to move and move and move. Okay? If you want to change anything with that object, basically, yes, you have please. So if this object, if you want to slow it down, or if you want to stop it, or if you want to change the direction in which it is moving, for any change you need to apply what? Force. And what kind of force? External unbalanced force. कल हमने balance and unbalanced force किया था, right? Balance force क्या करता है? कोई change ही नहीं करता. मैंने 10 न्यूटन डाला, आपने opposite से 10 न्यूटन डाला, any change? So external unbalanced force. Okay. That is first Newton's first law of motion. And with the help of that, we had discussed one important tendency of the object that is known as inertia of the object. So Yona, since you have come now, can you tell us more about inertia? What does inertia of any object mean? Huh? Yes. Exactly. Why are you always so late? What's the time? 10 minutes late. Yes, what you?
And we were there at 3. Yes, ma'am.
Still you were later. So we discussed first law of motion. First law of motion क्या है? Arya?
First law of motion. The body will stay at rest until any external force is applied, and the body will continue its motion until an external force.
Alright, अभी हम discuss किया. What is inertia, Yona?
Inertia is a tendency of the body to resist any change in the state of rest or of any motion.
You're just reading and explain. हम किसी छोटे बच्चे को explain करना हाँ भैया explain. कल इतनी बड़ी activity कर रहे थे आप सभी लोग. खींच ले रहे थे, नीचे पेन गिर जा रही थी. Why? Because this pen has inertia of rest. It doesn't move along. ठीक है? So what is inertia of motion या inertia of rest? अब basically अब हम बताते हैं. मान लीजिए यहाँ पे बहुत बड़ा mountain है. ठीक है? और हम मैं भी उस साइड आ जाते हैं. Please pay attention to it. There is a huge mountain slope. We all are witnessing 2 objects falling from there. Okay, falling down from the slope. One is very huge. You don't imagine polar bear and all, dancing down and all. There are 2 objects. One is very huge, and the other one is. जैसे सब का हो गया तो हम थोड़ा कंटिन्यू कर लेते हैं. You came before more.
Ma'am, Newton's means inertia.
Newton's first law of motion, that is inertia, is derived from Newton's first law. If he comes, Ayushi, if he comes this fast. Yes, so there is this whole slope you all are witnessing from that 2 objects are falling. आपका टास्क है गिरते हुए रुकाना. एक बहुत बड़ा ऑब्जेक्ट गिर रहा है, ठीक है, एंड एक बहुत छोटा ऑब्जेक्ट गिर रहा है. एक छोटा ऑब्जेक्ट और बड़ा ऑब्जेक्ट दोनों भी सेम स्पीड से गिर रहे हैं. This one is also moving with 2 meters per second. The huge object is also moving with 2 meters per second. Okay. Let's say Anirudh tries to stop there. Anirudh applies same force, okay, and he is able to stop the chota wala thing that is falling down. If he applies the same force to stop the bada wala, will it stop? No, because it is huge. But then the question is, both of them are moving with same velocity, right? तो ये रुक जाता है, दूसरा भी नहीं रुक पा रहा उससे. मास, इसका मास बहुत ज्यादा है, ठीक है, और इसका मास क्या था, कम था. तो जिसका मास ज्यादा है और एक प्रकार से वो क्या कर रहा है, Anirudh is trying to stop it, but then that object is resisting the change, right? वो जो दिशा में जा रहा है वही मूव करते जा रहा है, right? It is trying to resist any change. The other one was छोटा, तो उसे थोड़ा force लगा के रुक गया, थोड़ा करना पड़ा मेहनत पर रुक गया. So basically this inertia is the tendency of the object to resist. Okay, whenever you are trying to change anything with respect to its motion or state of motion or state of rest. The thing is, this inertia, from this example, you understand that inertia is dependent upon what? Mass of the object. More the mass, more is the inertia. Alright? More the mass, more is the inertia. So basically, if this is there, if of course I have to be very strict, I'll just keep it like this to be very safe basically. And if this is the paper, if I move it, ये वहीं पे नीचे गिर जाता है, ठीक है? पर ये बहुत हल्का पेपर होता है ऊपर, और मैं इसको मूव करती तो पेपर भी शायद साथ में आ जाता. And more heavy weight हम जो रखते हैं, पेपर वेट जो होता है, पेपर वेट हेवी है, so basically वो फिर आपने पेपर हटा लिया तो पेपर वेट वहीं पे रह जाता है. But more the mass, more is the inertia, more is the tendency to resist any change. Okay, so there are a few questions I was looking for the textbook. Did you bring NCERT textbook?
I'm excuse ma'am, when you were explaining with the two objects with different masses falling, ma'am, shouldn't the object with greater mass fall faster than the smaller?
Okay. Of course, it should fall faster than the other one. But I had made a scenario that both of them were moving with same velocity. मान लो यहाँ पे जो बड़ा move हो रहा था वहाँ पे काफी rough surface होता था. This is just the ideal. It's not. How do you call it? It is a made-up situation, right? So मैंने जो scenario बोला वहाँ पे देखिए, ideally of course it will fall with more speed. That will fall with the lesser due to the mass basically. But then we were just thinking, if the ideal scenario, if two things are moving, forget on the slope, even if on the normal road, if two things are moving, एक बड़ी बाइक, एक छोटी बाइक कुछ स्पीड से जा रही है और एक बहुत बड़ी ट्रक वही स्पीड से जा रही है, आप किसको रोक पाओगे? बाइक को. और उस उतने ही फोर्स से क्या ट्रक को रोक पाओगे? नहीं. बाय more the mass, more is the inertia. So the bike has less inertia compared to the truck. That is why it has more tendency to resist any change. Okay? So I have, if you understand the relation between mass and this, you should be able to answer this question. Okay, here the question is, what do you understand by inertia? Of course, that one goes with the definition, you will answer it. But the second question is, do all bodies have same inertia? Do all bodies have same inertia? No. No, we just saw. So, which body will have more inertia? How will you answer this?
Which body has the object with more mass?
So, more the mass, more is the inertia. And the other question from your textbook is, which of the following has more inertia? A rubber ball and a stone of the same size. Stone, because more mass compared to. A bicycle or a train?
Train.
A 5 rupee coin or a 1 rupee coin? So reason being 5 rupee coin has more mass. So these are pretty easy examples. Now comes some questions with respect to inertia. How inertia is useful as well.
Yes.
Okay. The question is, think logically why this one. When a carpet is beaten with stick, dust comes out of it. Explain. Or else, the other question which we discussed last class, why it is advised to tie any luggage kept on the roof with the rope? Why it is advised to tie any luggage kept on the roof of a bus or car with the rope? Because of inertia, but you just don't end by saying because of inertia. So why? Explain. Because of inertia, the object will
Stay at rest.
when the car or bike or bus starts due to inertia of rest, the object might fall down, okay? Or else when the bus is speeding up, so bus speed करके आगे निकल गई, but the object will still be in the inertia of rest and it will fall down. So to avoid that, you should fasten your luggage so that it doesn't fall. So now use the same logic. If I am dusting,
And when we put the luggage on the top of the car, isn't it connected to the car? Like that, so we going in inertia. So also the luggage is connected to the car. So why is it?
oh, good question. So he is saying luggage है, ठीक है, कार है, ठीक है, यहाँ पे जो ट्रांजिशन होता है, आपके भी जो पैर जो होते हैं, गाड़ी रुक जाती है तो आप थोड़ा टाइम लेते हो, पर लोअर बॉडी फिर भी काफी जल्दी रुक जाता है कंपेयर टू दी अपर बॉडी. दैट डजंट मीन लोअर बॉडी आल्सो. कभी-कभी मान लीजिए बहुत गाड़ी स्टॉप होती है, बट इतना अचानक झटके से स्टॉप होती है तो आप पूरी बॉडी भी आगे गिर जाते हैं. आपको समझ रहा है? कभी आपने देखा सीट से सड़क कर आगे आ गए, आपको क्या लगा गाड़ी रुक गई तो आप भी रुक जाते हो तुरंत, ऐसा नहीं होता है. पर गाड़ी जब स्लोली रुकती है तो आपकी बॉडी जो है स्लोली कवर अप कर लेती है, अपर बॉडी को थोड़ा टाइम लगता है, ठीक है. बट अगर बहुत अचानक से स्टॉप कर देते हैं तो आपके नीचे की बॉडी भी पूरी की पूरी आप आगे सरक कर आ जाते हो, ठीक है. एंड इनफैक्ट ज्यादा कुछ अगर आप खड़े हो तो आपके फीट भी जो है पीछे रह जाते हैं, उसकी वजह से आप पूरे के पूरे नीचे गिर जाते हो, ठीक है. So it's all with respect to the speed of the object नीचे का और ऊपर का. कल जब हम डिस्कस कर रहे थे, so what I was saying कि लोअर बॉडी के कंपैरिजन में अपर बॉडी और ज्यादा टाइम लगता है, ठीक है. इसके लिए आपका बेंडिंग जैसे होगा, अगर आपको हल्का सा जर्क लगता है जब बस में या कार में आप, अच्छा कार में तो नहीं खड़े रहते, पर बस में आप कभी खड़े हो या ट्रेन में आप गए हो और खड़े हो और जब हल्के से गाड़ी स्टार्ट हो रही तो आपका खाली कैसे ऐसा हल्का सा पुश लगता है. So आपको सिर्फ अपर बॉडी जाता है क्योंकि लोअर बॉडी ने मैनेज कर लिया है विद दैट थिंग. बट व्हेन इट मूव्स वेरी फास्टर, सो आपकी लोअर बॉडी भी नहीं कर पाती, काफी आप आगे तक पता है चलकर आप धक्का लगता तो आप थोड़ा आगे भी चलकर चले जाते. सो इवन बॉडी मूव्स बिकॉज द झटका इज मोर. सो इट ऑल डिपेंड्स अपॉन हाउ फास्ट द चेंज इज हैपनिंग, ठीक है. एंड इन द कार एंड थिंग, सो व्हेन द कार इज मूविंग, कार विल गो फास्टर कंपेयर्ड टू द object. An object will slide down because of the inertia. The same thing over here. Why did this question did not come to you when we were doing the paper thing? Even paper and this object was in contact, right? Why does it? Why this falls down? Because of the inertia. It has more mass. Okay. When you are moving, this one still because of the inertia will fall down. It won't go with the paper. It has inertia. It will resist the change. Okay. Now, coming to the dust and carpet. So this also has something to do with what? Inertia. So how will you explain? This whole chapter is about putting it in words properly. You know the answer, but you just cannot say why inertia. हाँ तो आप ऐसे नहीं कर सकते, आपको बताना पड़ेगा. So आपने अभी सीखा more the mass, more is the inertia, less the mass, less is the inertia. ठीक है. आपने जब इसको मारा है, झटका है, ठीक है. सो जो कारपेट है ये तो दूर चली जाती है, पर वहां के जो छोटे छोटे डस्ट पार्टिकल्स है वो तो वहीं रह जाते जहाँ थे, right? Carpet has moved and dust particle यहाँ पे रहकर या तो नीचे गिर जाएंगे तो हवा से उड़ जाता है, right? आपको समझ आ रहा है? So due to inertia of the dust particles, the carpet will move, but the dust particles will remain where they were and then fall off or fly away. ठीक है? This is why we hit them with sticks so that dust gets removed from the carpet. The other question that this one is the most important thing. This one is the most important one. So you know the answer. Trust me, you know the answer, but the question is so complicated it becomes very difficult to answer this. So the question is, an object experiences. अच्छा इसमें बुक में मत देखिए वरना तो आपको आंसर ही पता चल जाएगा. आप खुद से आंसर देने का ट्राई करें. And even Anirudh, you know about this topic. This was done yesterday. What are you doing? Are you doing maths homework in this class? What are you doing?
Checking.
What?
I'm just checking.
So the question is, an object experiences a net zero external unbalanced force. So एक object है, it is experiencing a net zero external unbalanced force. Is it possible for the object to be traveling with non-zero velocity? So एक object है, and this object is experiencing net zero external unbalanced force. So this can be any object, okay? It can be any object. So एक कोई object है, मैंने just randomly draw कर दिया, and this object is experiencing net zero external unbalanced force. Question is it possible for this object to be traveling with a non-zero velocity? So non-zero velocity. Yes. Traveling with non-zero velocity. Is it possible? Is it possible or not? Two of them are saying yes. So if you say yes, then you have to answer why yes. If you say no, then you have to say why. Okay. So there is one object उसपे net zero external unbalanced force.
And non-zero velocity means all velocity except.
हाँ मतलब 2 meter per second, 3 meter per second. Zero लिख देंगे मतलब वो मूव ही नहीं हो रहा है ना, इसके लिए उन्होंने नॉन जीरो बोला है. जीरो मतलब क्या है? बॉडी इज एट रेस्ट. हाँ पर उन्होंने अनबैलेंस फोर्स बोला है, बट सारे अनबैलेंस फोर्स मिलकर जो फाइनल कितना है? जीरो है. नेट का मतलब याद है कल हमने नेट का भी पता. नेट मतलब फाइनल जो इफेक्ट है इस बॉडी पे इन सारे एक्सटर्नल फोर्सेस का, वो फाइनल इफेक्ट कितना है? जीरो. तो अगर ये बॉडी पे एक्सटर्नल फोर्सेस एक्ट कर रहे हैं, जैसे अभी हमने देखा था ना ऑब्जेक्ट मूव हो रहा है तो उसको स्टॉप करना है तो एक्सटर्नल फोर्स लगाना पड़ेगा. इस केस में इस बॉडी पे एक्सटर्नल फोर्स एक्ट कर रहा है, बट द थिंग इज एक्सटर्नल फोर्सेस जो एक्ट कर रहे हैं वो सारे मिलाकर उसका रिजल्ट क्या है? जीरो. हाँ, so it will not move. So you have changed your answer. It will not move. It will move. They are not saying will move or not. They are just asking, is there any possibility that such kind of object have non-zero velocity? When will it not move? मुझे बताइए. इसमें मैंने डायग्राम में क्या बनाया हुआ है? It is at rest. मान लीजिए ये ऑब्जेक्ट पहले से ही मोशन में था, अब इसमें एक्सटर्नल फोर्सेस एक्ट करते हैं. ये पहले से मूव हो रहा था और अभी एक्सटर्नल फोर्सेस एक्ट कर रहे हैं. सो यहाँ से कल की तरह अनिरुद्ध कौन आर्यन ने अप्लाई किया था फोर्स, ठीक है. मान लीजिए यहाँ से आर्यन ने 10 न्यूटन का फोर्स अप्लाई किया था एक्सटर्नल, एंड अनिरुद्ध ने भी 10 न्यूटन का फोर्स अप्लाई किया था, एंड वो जो भी सारे एक्सटर्नल अनबैलेंस फोर्स है उनका फाइनल आंसर जो है वो कितना है? जीरो है. सो यहाँ 10 अप्लाई किया तो यहाँ पे भी 10, तभी जाकर नेट आंसर क्या होगा? जीरो. सो फाइनली इसमें जीरो ही है तो ये ऑब्जेक्ट का फिर क्या होगा? कुछ असर होगा इन दोनों का? सो व्हाट विल दिस ऑब्जेक्ट डू? कंटिन्यू मूविंग. सो द आंसर इज यस. एंड व्हेन इज इट पॉसिबल? So when it was already moving with uniform when it was already moving with uniform velocity or it was having uniform motion. Is this clear? Is this clear? The wording is complicated at times, student. Like you, at first you said yes. Did you have the same reason in your mind? Both of you, yes, that's the correct one. So this body will continue to move. Okay, so it will be traveling with non-zero velocity.
But ma'am, what if it is at rest?
Did they specify that its object was previously at rest? No. But if they specify it was at rest, and then you are applying the net zero external unbalanced force, will this move? No. Because आपने final net कितना force apply किया है? Zero. जब आप कुछ apply ही नहीं कर रहे हो, तो कुछ change ही नहीं होगा. ठीक है? ठीक है? So I think with respect to this part is done. Now let's do the most important part, which we only introduced, is the second law. So I hope Newton's first law is clear, that object will keep in the state of rest or continue in the state of motion until any external force is applied, okay, such that that external, what happens? And with the help of Newton's first law, we come across an important tendency of the object known as inertia. Okay, and inertia is very much helpful in cases, and we experience inertia in many of our day-to-day activities. But the most important one was Newton's second law. Newton's second law of motion. And please do not forget this. So, if I want to move this object, I have to apply force. How much force should I apply? Is dependent on how much change in momentum do I want to see. So, कल हमने momentum study किया था. Momentum of any body is what? Let's just write that. So, momentum of a body is given by what? It is given by mass of the body into its velocity. So whenever you apply force, you see change in its momentum. So abhi ye, like we asked Arman yesterday, I'm sorry. So we asked Arman yesterday that what is momentum of this body. He quickly said it is zero. Why? Because mass तो है, भले 10-20 ग्राम में 200 ग्राम होगा, but velocity इस object का क्या है अभी? Zero. So overall momentum क्या हो जाएगा? Zero. But I apply force, I see that it is moving with some velocity, right? And मान लीजिए this body starts moving with 5 centimeter per second, and if its weight was 200 grams, how much? 200 grams. Then together, what is the momentum? 5 2s are 10. So it is 1000 grams centimeter per second. Okay. You just do the calculation. I've just done mass into velocity. Okay. So basically, when you apply force, you will see that the momentum of the body changes or not.
Yes.
It changes, right? So Newton gave his second law, and he said that force is directly proportional to the change in momentum that you see. So ये 0 से बढ़कर अभी कितना हो गया था? 1000 हो गया था. ये पिछले एग्जांपल में हमने जो देखा 0 था पहले, and अभी मैंने इसमें force apply किया था तो 1000 हो गया था. So basically it is directly proportional to how much change do you want to see. Change in what? Change in the momentum. That too with respect to time. टाइम के टर्म्स में क्यों है? बिकॉज आपको कम टाइम में चाहिए तो आपको कम फोर्स अप्लाई करना पड़ेगा या ज्यादा आपके पास कम टाइम है और आपको जल्दी से यहाँ से वहां जाना है. आपको किसी ऑब्जेक्ट को, ठीक है, अब मान लीजिए कि आपको यहाँ से वहां कोई चीज को डालना है. आपके पास पूरा दिन है, बहुत हैवी ऑब्जेक्ट है, पूरा दिन है, तो आप आराम से टाइम लेकर हल्का फोर्स लगा कर सरका कर वहां पहुंचा देंगे. बट आपके उस टाइम में आपको बहुत कम समय में डालना है तो आपको बहुत फोर्स लगेगा, राइट? कम समय में जल्दी वहां पहुंचना है। तो बेसिकली अब कम टाइम ले रहे हैं तो फोर्स कितना लगता है, ज्यादा लगता है, और ज्यादा टाइम ले रहे हैं तो फोर्स कितना लग रहा है, कम। सो बेसिकली टाइम के साथ उसका रिलेशन कैसा है, इनवर्सली। हैव यू कम अक्रॉस इनवर्स एंड डायरेक्ट वेरिएशन? नहीं किया है, मैथमेटिक्स में किया होगा, डायरेक्टली प्रोपोर्शनल, इनडायरेक्टली प्रोपोर्शनल, इनवर्स वेरिएशन,
Inverse and direct proportions.
लाइक आई गिव यू सम एग्जांपल। आपके पास 2 रुपए है तो आप 2 चॉकलेट खरीद सकते हो। आपके पास 10 रुपए है तो आप कितनी चॉकलेट खरीद सकते हो, 10। मतलब पैसे बढ़ेंगे तो चॉकलेट्स भी बढ़ेंगी, ठीक है। सो यहाँ पे क्या है, एक क्वांटिटी बढ़ रही है तो दूसरी क्वांटिटी भी बढ़ रही है, ठीक है। इफ मनी इज मोर, नंबर ऑफ चॉकलेट्स इज आल्सो मोर, ठीक है। बट मान लीजिए आपको ये बिल्डिंग बनानी है, ठीक है, ये बिल्डिंग बनानी है, आपने 2 आदमी को रखा है काम पे। सो 2 आदमी को 10 दिन लगा रहे काम करने के लिए, 2 आदमी 10 दिन लगा रहे काम करने। अगर आप 2 आदमी से आप बहुत ज्यादा आदमी ला देते, आप 10 आदमी लगा देते, सो टाइम ज्यादा लगेगा या कम लगेगा, कम लगेगा। तो यहाँ पे क्या हो रहा है, वर्कर्स बढ़ रहे हैं तो टाइम कितना लग रहा है, कम लग रहा है, राइट। सो ये क्या, इनवर्स प्रोपोर्शन। एक चीज बढ़ रही है और दूसरी चीज बढ़ रही है तो इसको बोलते हैं डायरेक्ट वेरिएशन। क्या बोलते हैं, डायरेक्ट वेरिएशन। एंड ये यहाँ पे अगर नंबर ऑफ वर्कर्स बढ़ा दिए तो कम टाइम लग रहा है, तो एक चीज बढ़ रही है तो दूसरी चीज क्या हो रही है, घट रही है। सो इसको बोलते हैं इनवर्स। और आप इनवर्स जो रिलेशन है, इनवर्स रिलेशन डिनोमिनेटर के, सो एफ इज इनवर्सली प्रोपोर्शनल टू टाइम एंड फोर्स इज डायरेक्टली प्रोपोर्शनल टू चेंज इन मोमेंटम। एंड इन दोनों को क्लब करके टुगेदर लिखा जाए, सो फोर्स इज डायरेक्टली प्रोपोर्शनल टू चेंज इन मोमेंटम एंड फोर्स इज इनवर्सली प्रोपोर्शनल टू time. Are you getting what I am trying to say? I know you are not aware, that is why it is difficult, but then थोड़ा अगर यहाँ से रिलेशन समझ गया है, अब शायद लॉकडाउन में शायद भूल गए, ऐसा कभी जरूर हुआ होगा। This comes in 7th or 8th grade. It comes in 7th or 8th grade. These two things, one is increasing, other is increasing, it is direct proportion. One is increasing, other is decreasing, it is inverse. ठीक है। So this is the proportionality thing. So force, let me just write completely because we are doing. So force is directly proportional to change in momentum and it is inversely proportional to time taken. All right. So now I know that, you know, if let's say this was the body, इस पे कुछ force apply किया हुआ है. So let's say it was moving, already moving with, what does u represent? In last class we know. We have done initial velocity. So let's say this object M was moving initially with velocity u, and then Arman comes and he applies force. Force applied. So what will happen? Arman applies force from this side, so this speed will increase, and what will happen? This same object will start moving with velocity v, because v represents what? Final velocity, right? So initial velocity कितना था? M into u. So let's say initial. Okay, I'll give you an example now. Let's say if this mass of this object was 1 kg and initial velocity was 1 meter per second, then can you tell me what is initial momentum of this body? 1 only, because momentum is what? Mass into velocity. So 1 into 1 will be what? 1 only, right? So what is the initial momentum? Initial momentum, I'm just writing momentum like this, is equal to 1, and what is the unit? Kg meter per second. Kg meter per second. ठीक है? Now the same body may he applies force and it starts moving with velocity 5 meter per second. So can you tell me the final momentum now?
5 kg meter per second.
5 kg meter per second. So can you tell me how much is the change in momentum, because we require change in momentum? How much is the change? Final velocity, final momentum minus initial momentum. So how much is that? Change in momentum is how much? 4 kg meter per second. But then I also need how much time did he take to specify how much force he applied. So let's say he did all this thing in just 1 second. He applied the force very quickly. So time taken is how much? 1 second. All right. So how much force did he apply? Force applied by him is directly proportional to some value, which I get 4 divided by 1 is 4. Okay. So this number wise, if we do number wise, so you understand that for getting change in momentum, you subtracted 5 minus 1, right? When I asked you what is change in momentum, so I can also write this as change in momentum as final momentum minus initial momentum. Are you understanding?
Yes.
5 did I write final first? And divided by time. Again, force is directly proportional. Final momentum को हम कैसे लिख रहे थे? Final momentum is, हमें यहाँ पे of course I have just given random values 5 meter per second. So if 5 is not given, then what is the final velocity represented by? V. So what is final momentum? Mass into velocity. So M V, right? What is the initial momentum then? How do I represent it? M U. M U. Then how will this look? It will look like, what is final momentum? M V minus M U upon T. Shall I erase this one? I don't think so. You need to understand this. I hope whenever you 9th grade with, I don't know if you will be doing variations, but you have probably done this in 7th or 8th. Alright, so let's bring this over here. So now I have got very much crisp answer directly proportional to MV minus MU upon T. I can take mm common. If I take mm common, then I am left with V minus U upon T. Can you see that? And Z, can you tell me V minus U upon T कौन सी physical quantity है? हमने first chapter में की है. Yes. So I can replace this whole thing with acceleration. What happened? So I can replace this whole thing with acceleration because V minus U upon T is what? Acceleration. So force is directly proportional to mass into acceleration. Alright. So this was a complex formula that we knew, that force is directly proportional to change in momentum upon time. And through that second law, I got one important relation, that force is given by mass times acceleration. Now the thing is, since you are not aware, this is, हम कभी अभी तक हमने जो भी इक्वेशन लिखा हुआ है उसमें क्या यूज करते हैं? इक्वल टू साइन. ये कौन सी साइन है? प्रोपोर्शनैलिटी साइन. So I need to remove this proportionality sign, and when we remove it, we get one constant. We have to replace it with a constant. Constant क्या होता है? कोई एक constant मतलब भी आपको पता ही. Constant मतलब क्या होता है? एक fixed number, right? Constant मतलब जब मैं बोलते हैं acceleration constant है. हाँ मतलब acceleration constant in the sense that value is constant. आप हमेशा constant speed से जा रहे मतलब आप 1 सेकंड में भी 5 मीटर पर सेकंड, नेक्स्ट सेकंड में 5 मीटर पर सेकंड, तो कांस्टेंट है वैल्यू. सो यहाँ पे when you replace this proportionality sign with equal to sign, you have to introduce one constant. Okay, and this value mostly it's not that we give any value on our own. ठीक है, आप अभी ये हमेशा देखोगे कि नेक्स्ट चैप्टर में भी फिजिक्स में हम पहले कैसा उनका रिलेशन है वो चेक करते हैं, बाद में प्रोपोर्शनैलिटी साइन इंट्रोड्यूस करते हैं. एंड फिर वो प्रोपोर्शनैलिटी साइन जो है कांस्टेंट इंट्रोड्यूस करने के बाद ये कांस्टेंट की कितनी वैल्यू हमें ढूंढना पड़ता है. सो यूजुअली हम एक्सपेरिमेंट करके करते हैं, फाइंड आउट करते हैं वैल्यू कितनी है। इस केस में हमने k की वैल्यू जो है डिपेंड्स कौन सी क्वांटिटी की बात हो रही है। सो यहाँ पे हमने k की वैल्यू 1 दे दी है। क्या दे दी है? 1। क्या दे दी है? 1। सो k की वैल्यू 1 हो जाएगी और हमेशा k की वैल्यू क्या रहेगी? 1 ही रहने वाली, राइट? बिकॉज वैल्यू इज व्हाट? कांस्टेंट। हमने ट्राई किया है कि k इज प्रोपोर्शनैलिटी कांस्टेंट। वी कॉल इट व्हाट? k इज प्रोपोर्शनैलिटी कांस्टेंट or constant of proportionality, whichever way you hear it, both are same. So it is constant of proportionality or proportionality constant, and we get its value as 1. We take its value as 1. So when you take its value as 1, how will this equation now look? F is equal to m a. Are you getting? So आपका equation बहुत easy बन गया है. Force is given by formula mass into acceleration. Is this clear? So आपको किसी भी ऑब्जेक्ट का एक्सेलरेशन पता है और उसका मास पता है तो आपको उसका फोर्स भी पता चल जाएगा. Is this clear? So what is happening over here? First, the first thing that you need to remember is what is momentum of a body? Momentum of a body is product of mass and velocity of that body. ठीक है? This is not Newton's second law. ये हम क्यों कर रहे हैं? न्यूटन सेकंड लॉ यहाँ पे है. दिस इज न्यूटन सेकंड लॉ. बट सिंस वी आर यूजिंग वर्ड मोमेंटम एंड यू आर नॉट अवेयर व्हाट इज मोमेंटम, सो यू शुड फर्स्ट राइट व्हाट इज मोमेंटम. ठीक है? देन ड्रॉ दिस पिक्चर, देन राइट न्यूटन सेकंड लॉ एंड राइट दिस फोर्स इज डायरेक्टली प्रोपोर्शनल टू द rate of change of momentum. So if I am reading this, I will say rate of change of momentum with time. Rate at which it is changing with respect to time. I know it is quite a lot, but like you all have now remembered all the 3 kinematic equations, right? Have you or not?
Yes, ma'am.
So this is the third one. Force is equal to mass into acceleration. You will be using this more than the other one in your higher grades. Force is equal to mass into acceleration. नहीं याद रहे तो force मान है याद रखो. ठीक है? आपको याद रह जाएगा. All right? Quickly write this down neatly. You know, before let others write, can you tell me all the 3 kinematic equations of motion?
Yes, ma'am. P minus V is equal to 80.
What did you say? I heard minus.
Plus
Go again. I missed something. Go again.
3 plus Q is equal to 80.
थोड़ा गलत हो गया है.
Minus क्या है?
V is equal to U plus 80 और आप U पहले बता रहे हो तो U opposite से में जाता तो minus हो जाता. So V minus Q is equal to 80. But stick to the trend in which we say D is equal to U plus 80. So it is equal for U. Please write this. It's very important. Do not miss any step. So K is given as 1, and when K is taken as 1, we get this final expression, which is force is equal to mass into acceleration. It's very important. And in last class we discussed what is SI unit for force. Do you remember? या भूल गए? Newton. Represented by letter N. Small n or capital N? Capital N. Never small. All right. Finish this. Whose book is this?
Someone.
अभी मुझे हुआ था कि मैं सीए एक्सरसाइज 4.2 तो यहाँ पे ऑप्शन से किए हुए हैं.
ये थोड़ा सा क्वेश्चन पता है ना क्या क्या हुआ है. मैथ्स के कितने चैप्टर्स हुए हैं?
मैथ्स के 3
March के 4.
3 हुए.
3 पूरा कंप्लीट हुआ है.
हाँ. नंबर सिस्टम. हाँ. And Jordan coordinate. Jordan. Science.